Hello and welcome to Curious Minds with Mzungu Baridi. This video is about a man who lived over 2,600 years ago and invented a great thing that allows you to easily measure the height of palm trees, for example. Chapter 1. The man this video is about was called Thales of Miletus. He was a very important thinker who lived in Greece over 2,600 years ago. In his day, people often explained natural phenomena with gods and myths. But Thales was already a curious mind back then. He saw the world with curiosity and wanted to explain it through observation and logic. That is why he is still often referred to today as the first philosopher and first scientist of the Western world. At that time, there were 7 sages in Greece, and Thales was one of them. Some of his great discoveries and ideas. Thales was the first to think the world can be explained without stories of gods, only with nature and logic. That was revolutionary. He was the first to propose the theory that all life comes from water. He is said to have predicted a solar eclipse, 585 BC. Mathematics. The theorem of Thales. He measured the height of the pyramids with the help of shadows. You can find out how to measure heights yourself with very simple means and a little bit of arithmetic in this video. He also used geometry to calculate the distance of ships at sea. He observed stars, solstices, and seasons. And much more. Why was and is Thales so important? He began to investigate phenomena that were otherwise attributed to the gods, making him the great-grandfather of modern science in Europe. His teachings also influenced philosophers such as Pythagoras and Aristotle. Thales also showed that curiosity and observation can help us understand the world without having to fear the gods. And without any superstition. In keeping with the spirit of this channel, curiosity is the engine of knowledge. Chapter 2. And now I will explain how you can build a real altimeter, just like the one Thales used. What do you need? A straight stick, e.g. 1 meter long, or measure it accurately. A tape measure or folding rule. If necessary, you can also count your steps. And, of course, the sun must be shining, so that you have a shadow that you can measure. A tree or tall object that you want to measure. Important. The accuracy of the results depends on how accurate your measurements are, knowing the exact length of the measuring stick and how deep and straight it is stuck in the ground. If your stick is 1 meter long and it is stuck 5 centimeters into the ground, you must of course subtract these 5 centimeters from the length of the stick, because only the visible part of the stick is relevant for the measurement. The visible part is therefore only 95 centimeters long. As the position of the sun is constantly changing, the speed at which you take the measurements is also crucial for accuracy. In most cases, such measurements do not require 100% accuracy. Here's how to do it step by step. It's very simple. In this video I explain how to measure vertical objects. Let's say you want to determine the height of a straight tree. Wait until it casts a nice shadow and then stick the stick vertically into the ground, like a small stake. It must be straight. Wait until the stick casts a clear shadow. Immediately measure 2 things, preferably at the same time, because the sun is moving. How long is the shadow cast by the stick? E.g. 2 meters. How long is the shadow cast by the palm tree? E.g. 20 meters. Write both values down on a piece of paper. Now you can calculate like Thales. The simple rule is, no matter how long the shadows are, they are always in the same proportion to the objects. This means that the shadow cast by the stick only differs in scale from that cast by the tree. All you have to do is figure out what this scale is. If you know that the ratio of both objects and their shadows is always the same, then the height of the tree on a smaller scale is also equal to the height of the stick. A very simple example. Here are your known variables. Your stick is 1 meter high. The shadow of the tree is 20 meters long. The shadow of the stick is 2 meters long. Calculation. Height of tree equals 1 meter, stick length, times 20 meter, tree shadow, divided by 2 meter, stick shadow, equals 10 meters high. If your stick is shorter, e.g. only 80 centimeters, the whole thing looks like this: visible stick equals 80 centimeters high, 0.8 meter. Shadow of stick equals 1.2 meter. Shadow of tree equals 18 meter. Height of tree is equal to 0.8 times 18 divided by 1.2 is equal to 12 meters high. Just use the shadow to measure how tall your friends are. Usually, it is enough to be able to determine the approximate height of an object. To be as accurate as possible, you can also mark the stick with cm measurement so that when you stick it in the ground, you can determine the exact length of the shadow casting part of the stick by reading how deep the stick is in the ground on the scale and subtracting this value from the length of the stick. Here's another question, maybe you can solve it. What if you want to know the length of Juma's shadow and you know his height, in this example, 1.8 meters? So you would have the following values: Juma's height, 1.8 meters. Visible length of the measuring stick, 1 meter. Shadow length of the measuring stick, 2.2 meters. What would be the length of Juma's shadow? To do this, you use a rule of 3 formula, proportion divided by rule of 3. Since the sun's rays are parallel, the triangles are similar. You could also say that the ratios are the same, just on different scales. Height of Juma divided by height of the measuring stick equals shadow of Juma divided by shadow of the measuring stick, or rearranged, shadow of Juma equals height of Juma times shadow of the measuring stick divided by height of the measuring stick. Substituted. Shadow of Juma equals 1.8 meters times 2.2 meters divided by 1 meter. Answer: the shadow of Juma is 3.96 meters long. Why not try it out for yourself to see how accurate your measurement is and leave me a comment telling me how accurate your measurement was. But what if the object you are measuring is not vertical? I would be delighted if you could find a solution yourself or discuss it with your teacher. Or you could simply wait for my next video. I hope you enjoyed this lecture and that it made you a little smarter. Don't forget to like the video and subscribe to the channel. If you want to support me financially, take a look at the video description, where you will find my email address. I look forward to the next video, and until then, don't forget, curiosity is the engine of knowledge.